Okay, another rate of change example. Uh, Here I have an example that says the radius r of a sphere, the radius r of a sphere increasing at a rate of 3 centimeter per second. Rate increasing, radius r increasing at a rate. This means dr to dt is equal to 3 centimeters per second. This is the increase in r to dt in time. Every second, the radius of a sphere increased at 3 centimeters. Find the rate of at which the surface area of the sphere increasing when the radius is 2 centimeters. So the radius is given as 2 centimeters. This is also important. And we need to find the surface area, the rate at which surface area. So we need to find the S. Let's name S as a surface area here. Find the rate at which the surface area of the sphere increasing. So we need to find the S to dt at radius r equal 2. This value is how much? That's great. So what is surface area first? Surface area of a sphere is 4 pi r square. This formula is the formula of surface area of the sphere. Okay, if we do like the chain rule here, we know that the s to dt we need to find is equal to the s over dr. Why we use this? Because already we have s as a function of r times dr to dt, right? Which we have it. That's great. So what is the s over dr? The s over dr is where we are deriving both sides of this formula. Sorry, it's 4 pi r square, right? 4 pi r square according to the r as variable. So this will be equal to 4 pi, we can put it outside because it's constant. The derivative of r squared to dr, the answer is 4 pi. Derivative of r squared is 2r. And r prime, which is dr, this is 1. What left is 8 pi r, and this is again the s over dr. Now we found the s over dr. Now this we have it. The s over dr, we got it. We still have to find dr over dt, but we have it already. It's 3 centimeters per second. So directly I can substitute to have the s to dt. The s to dt is the s dr, which is 8 pi r multiplied with 3 centimeter per seconds, right? But also we still have to know r, and he said we should do this at r equal 2 centimeter originally. So it's 8 times pi r, which is 2 centimeter, again times 3 centimeter per second, and we find the final answer to be 2 times 3, 6, 6 times 8 is 40. 8 pi centimeter times centimeter is centimeter square per second. Be careful, because we are finding the s to dt. To dt means to second, and the ss is a surface area. It should be in centimeter square because r is given already in centimeter. This is an example. We still have time. Let's start another example. Another example says the volume V of a sphere increases at a constant rate of 4 centimeter cube per second. So we have increasing in volume according to time. It's 4 centimeter cube per second. Because it's volume, its unit is cube. This is given, right? What else? What else we have? Find the rate at which the radius r of a sphere changes. This means we have to find the rate of changing of r in terms of time, the r over dt. What is it equals to? And it should be in centimeter per second, because the radius given in centimeter and the time is in seconds. When r equal 3 centimeter and when r equal 12 centimeter, we have r equal 3 centimeter first and then r equal 12 centimeter second. We have two cases here, right? So we need to find the r over dt. We write the chain rule of dv over dt. It's equal to dv dr times dr dt. Why we wrote it that way? This is given. This we need to find the r over dt. We still don't know about dv dr. I use dv dr times dr over dt in this chain rule because we're talking about sphere. And what is the volume of sphere? Volume of sphere is a formula. We know it, right? What is the volume of sphere? Volume of sphere is 4 over 3 pi r cube, right? 4 over 3 pi r cube. If we derive these two sides according to radius, because volume is given as function in r, so dv over dr, dv over dr will be equal to derivative of 4 over 3 pi r cube to dr, right? What is this? dv over dr will be equal derivative of r cube. It's a 3 multiplied with 4 over 3 pi and r square, right? Times the derivative of r to the r, which is 1. So this is the final dv over dr. It's 4 pi r square. Now, dv dt, it's given. It's 4. Let's put the unit at the end. And this is 4 pi r square. We need to find the r dt, right? In general, the r dt, the r to dt is 4 divided 4 pi r square by dividing both sides by 4 pi r square over here, right? We end up with the r over dt is equal to 1 over pi r square. Now he wants me to find the r over dt according to what? According to two different ways, where r is 3 centimeter first and then r is 12 centimeter. For r equal 3 centimeters, this implies dr to dt will be equal 1 over pi r square. So it's 1 over 9 pi. 1 over 9 pi, since we're finding dr to dt, so it's centimeter per second, right? Centimeter per second. And then for r equal 9, not 9, it's 12, right? 12 centimeter. This implies that the r to dt is equal 1 over pi r square, but this time r is 12, so 1 over 144 pi, also centimeter per second. And see you next example. It will be good, very good example to for rate of change.